Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is section 10.3. The last conic section is the parabola. We studied parabolas before uh, when, as graphs of quadratic functions. When we studied quadratic functions, a quadratic function can be written like this or like this. And we have seen that if it is written like this, then if a is positive, the graph is upward. The graph of a quadratic function is a vertical parabola like this. If a is negative, the graph opens downward. And we can see the vertex immediately from here. The vertex is h and k. Okay, the vertex is h and k. And this line is the axis of symmetry, and it's a vertical line in this case. And it has the equation x equals h, where h is the x-coordinate of the vertex. And if the equation is written in this form, then also if a is positive, it opens upwards. If a is negative, it opens downwards. And we can find the vertex by applying this formula. H, which is the x-coordinate of the vertex, is negative b over 2a. And we can find k by finding f of h, by replacing x by h and finding y, which is k. So we can find the vertex even if the equation is written in this form. Well, now the definition of the parabola in general, it is the set of all points in a plane that are equidistant from a fixed line called the directrix and the fixed point called the focus. And this point is not on the line. Okay, so here, this is the graph of a parabola. This is a horizontal parabola. Okay, we call this point the vertex. This point inside is the focus, and this line is the axis of symmetry, and this line is called the directrix. Now, any point on the parabola, the distance from this point to the directrix, the vertical distance, is equal to the distance from this point to the focus. Okay, equidistant. The distance, this point also, which is the vertex, is equidistant from the focus and the directrix. So the distance from the vertex to the focus is equal to the distance from the focus, the vertex to the directrix. And we will call this distance absolute value of P, absolute value of P. So when we use this definition, we will find that the equation of the parabola is y square equals 4px if the parabola opens to the right and to the left. Okay, if it's a horizontal parabola, we have y square. If we have y square, then if we replace y by negative y, the graph does not change, and the equation does not change. So this means that the graph is symmetric about the x-axis. So the graph opens to the right or to the left. If P is positive, the graph opens to the right. And if P is negative, the graph opens to the left. The coordinates of the focus, if the graph opens to the right, would be P and 0. The directrix will have the equation x equals negative P. If the graph opens to the left, then also the focus would be, the coordinates of the focus would be P and 0, because P in this case would be negative. And the directrix will have the equation x equals negative P also, because P would be negative. Okay. And if the equation is x squared equals, of course, notice that in the equation of the parabola, we don't have y squared and x squared. One of the variables is squared and one of the variables is raised to the power 1. So when we have x squared, the parabola opens up or down, because if we replace x by negative x, the parabola, the equation, the graph do not change. So the graph is symmetric about the y-axis. So it opens up or down. This is the vertical parabola. Also, you can think if y has power 1, it's a function. So the vertical parabola is a function, while the horizontal parabola is not a function. Okay. And if the graph, if p here is positive, then the graph opens up, and if p is negative, then the graph opens down, and the vertex will be 0, 0. We are discussing always here the parabola with vertex at the origin, with vertex 0, 0. And this distance is absolute value of b from the vertex to the focus, and this distance from the vertex to the directrix is also absolute value of p. The focus has coordinates 0, p, because it lies on the y-axis, and the directrix is a horizontal line, and it has the equation y equals negative p. So let us solve some exercises or examples. Find the focus and the directrix of this parabola, then graph the parabola. Well, y square equals 4px. So 4p is 12. This means that p is 3. Now y square, so the graph opens right or left. P is positive, so the graph opens, the parabola opens to the right. Of course, the vertex is 0, 0. We start by the vertex. And now absolute value of P is 3. So I go 3 units to the right. This would be the focus. So the focus has coordinates 3 and 0. And I go 3 units to the left, and I draw the directrix. The directrix has the equation x equals to negative 3. And the parabola opens to the right. So this is the graph of this parabola. Here the same. Please try this problem by yourself. P is 2 and y square, so the graph again opens to the right. There is a line called lattice rectum, and the lattice rectum is the line that passes through the focus line segment, and it's parallel to the directrix. So it passes through the focus parallel to the directrix with endpoints on the parabola. So for this parabola, this line segment is called the lattice rectum. It passes by the focus parallel to the directrix. Endpoints are on the parabola. If the parabola opens upwards or downwards, this would be the lattice rectum, passes by the vertex parallel to the directrix, endpoints on the parabola. This lattice rectum, this line segment, determines the opening of the parabola. So here, when we graphed, I'm not sure whether the opening is like this or like this, okay? So how to determine the opening of the parabola? We use the lattice rectum. So finding lattice rectum will help us to graph an accurate parabolas. So what is the length of the lattice rectum? The length of the lattice rectum is absolute value of 4p. Absolute value of 4p. So 2p here up and 2p down. 2p to the right and 2p to the left. The length, all of the line segment, is absolute value of 4p. So let us find the focus, the directrix, and sketch the graph of this parabola. I have x square equals, so the graph opens up or down. -8, so the graph opens down, okay? 4p is -8. So p is -8 over 4, which is -2. The vertex is 0, 0. So I start with the vertex, and then absolute value of P, absolute value of P is 2. So I go 2 units up from the vertex and 2 units down. The graph opens downwards. So here I'll have the directrix. The equation of the directrix would be, it's a horizontal line. So the equation of the directrix is y equals to 2. The focus, this would be the focus, and the focus has coordinates 0 and -2. Now let us find the lattice rectum. Absolute value of 4p is 8. 4p is -8, so it's absolute value of -8 in fact. That's the lattice rectum, 8. So I go 4 units to the right up to here, and 4 units to the left up to here. So this line segment is the lattice rectum, and the parabola passes by these 2 points. So now I sketch the graph of the parabola like this. Okay, so this would be the graph of this parabola. Also here, the checkpoint, please do the same because it's similar. X square negative b, so the graph will open to the downwards. Find the lattice rectum and find the focus and the directrix. Find the focus and directrix of each parabola with the given equation. Then match each equation to one of the graphs that are shown. I can see that here I have y square equals 4x. So y square means the graph opens right or left, but p is positive, so the graph opens to the right. The only graph opens to the right is this one. So immediately I can say that the graph of equation 1 is C. Y square is negative, opens to the left, so the graph is D. X square is positive, the graph opens up and down. 4, it's positive, so the graph here is A, and the graph here is B. But let us try to find the focus and the directrix without graphing, although you can graph and then find the focus and the directrix, no problem. In all the cases, 4p is 4, so p is 1. Okay, in all the cases, p is 1. So let me write it here. 4p is 4, then p is 1. Uh, p is 1 here and p is -1 here. Okay, so p is 1 in the first 2 cases and p is -1 in the second, in 3 and 4. Well, here we said that the graph opens to the right. When the graph opens to the right, okay, the focus has coordinates p and 0. So the focus here has coordinates 1 and 0, and the directrix will have the equation x equals -1. While here, -4, the graph opens to the left, okay? So the focus here in number 4 has coordinates, okay? P and 0 also, but P is -1, so -1 and 0, and the directrix x equals 1 because it's to the right of the y-axis, okay? Here, x squared, here the graph opens upwards. And if the graph opens upwards, the focus has coordinates 0 and p, so 0 and 1, and the directrix will have the equation y equals -1. Here the focus, the graph opens to the downwards, so the focus is 0 and -1, which is p in this case, and the directrix has the equation y equals to 1. Find the focus, the directrix, and sketch the graph of the parabola. Well, y square equals 16x. The graph will open to the right or to the left. 16 is positive, so the graph opens to the right. Okay. Absolute value of p is 4p is 16, So P is 16 over 4, which is 4. So absolute value of P is 4. The vertex is 0, 0. So I start from the 0, 0, the point 0, 0. I go 4 units to the right and 4 units to the left. This would be the equation of the directrix, and this would be the focus, 4 and 0. And this would be the parabola. To graph an accurate parabola, absolute value of for P is 16. So I go 8 units up and 8 units down. And the parabola will pass by these 2 points, and these 2 points are the end points of the lattice rectum. And this is the graph of the parabola. Y square equals negative 8x. The parabola opens y square, so right or left, negative, so the parabola opens to the left. Immediately you can know this from the equation, and this will help you because the vertex would be here and the directrix would be here. So you can find P by equating 4P to negative 8, so P is negative 2. And then absolute value of P would be 2. And absolute value of P is the distance from the vertex. It opens to the left, so I go right and left. This would be the equation of the directrix. X equals negative P. In this case, alt would be 2. And the focus would be here. So the focus is negative P and 0. The focus always P and 0. Or you can see that it's negative 2 and 0. I need the lattice rectum. Absolute value of 4P is 8. So I go 4 units up and 4 units down. This point and this point are the endpoints of the lattice rectum. And here is the vertex. It has to pass by the endpoints by the lattice rectum. And this is the equation of the parabola. Now I have x squared and positive 12. So the parabola opens upwards. Okay. And here will be the directrix. So the vertex is 0, 0. 4P is 12. P is 3. Absolute value of 4P is 12. So I have all the information necessary to sketch the graph. Vertex 0, 0. I go 3 units up. This would be the focus because the graph opens up. So the focus has coordinates 0, 3. I go 3 units down. I sketch the graph of the directrix. It's a horizontal line with the equation y equals negative 3. And now I can draw the lattice rectum. 12, I go 6 units to the right. I reach this point. And 6 points to the left. I reach this point. So this is the lattice rectum, the endpoints of the lattice rectum. I sketch the graph of the parabola from the vertex and let the graph pass by the lattice, the endpoints of the lattice rectum. This is the graph of the parabola. X squared equals negative 16. X squared, so the graph opens up or down. Negative, it opens downwards. Here would be the directrix. The vertex is clear that it is 0, 0. 4P is negative 16. P is negative 4. It's negative in this case. That's why the graph opens downwards. Absolute value of 4P is 16. That's the length of the lattice rectum. 0, 0 is the vertex. I go 3 B is negative 4. Absolute value of P is 4. So I go 4 units up, 4 units down. This is the focus. The focus has coordinates 0 and negative 4. This is the directrix. The directrix has the equation y equals to 4. The graph opens downwards. 16, the lattice rectum, I go 8 units to the right, to the left, and 8 units to the right. These are the endpoints of the lattice rectum, and the graph will be, the graph of the parabola will be like this. Now, if the equation is not written in the standard form, remember, you have to solve the equation for y square or x square. So you solve it for y square, and then for p would be 6. P is 3 over 2, and absolute value of 4p is 6. Y squared, the graph opens right or left, positive, so the graph opens to the right. And the directrix would be here. The vertex is 0, 0. Now from the vertex I go 1.5 units to the right and 1.5 units to the left. The directrix has this equation, x equals negative 3 over 2, and the focus has the coordinates 3 over 2 and 0. The vertex is like this. The length of the lattice rectum is 6. I go 3 units up and 3 units down, and I sketch the graph of the parabola. Also here, I solve it for x squared. So 8x squared is negative 4y. I divide by 8. Negative 4 over 8 is negative half. Now x squared, so the graph opens up or down. Negative, so the graph opens down. And this would be the directrix. Absolute value of 4p is half. This is the length of the lattice rectum. 4p is negative half. P is negative half over 4. That's negative 1 over 8. So absolute value of P is 1 over 8. The vertex is 0, 0. Now if this is 1, I go 1 over 8 units. 1 over 8 units. So the equation of the directrix would be y equals 1 over 8. And the focus has coordinates 0 and negative 1 over 8. And the graph opens, as we know, downwards. And half is the length of the lattice rectum. So I go 1 over 4 units. 1 over 4 units right and 1 over 4 units left, and I graph the parabola. Now the second type of questions about parabola, about conic sections in general, find the standard form of the equation. So either graphing or find the equation. He will give you some information, and as usual, I'll sketch, I'll draw the graph, I'll graph this information to find out information, help me to find the equation of the parabola. The focus is 5, 0. So this is the focus. What do I get from here immediately? That absolute value of P is 5. And the directrix has the equation x equals negative 5. So this is the directrix. So it's clear to me that the vertex is 0, 0, and that absolute value of P is 5, and that the vertex is here and the graph opens to the right. The graph opens to the right, so P is positive, and the graph opens to the right, so the equation is y squared equals 4px. because the graph opens to the right. So the equation is y square equals p is 5, so 4 times p 20x. That's the equation of the parabola. Same, the focus is 8, 0. Same question, 8, negative 8. Directrix is here, so the vertex is 0, 0. It opens here, p is 8. So y square equals 4 times 8, 32x. So when you sketch the graph of the information, you will find out the direction of the up, down, right, left of the parabola, and then you will know the equation. You find p and you just write the equation immediately. So that's very easy. Negative 5, 0, that's the focus. 5, x equals 5, equation of the directrix. So p is negative 5. P is negative because the focus is here. And the graph will open to the left. Opens right or left, the equation is y square equals 4px. P is negative 5. So the equation is y square equals negative 20x. Focus is 0, 15. So let us say that this is 15. So here the focus. And here negative 15. So y equals negative 15, that's the directrix. Always the directrix is behind the parabola. So this is the focus is inside the parabola. So the parabola opens like this, upwards. So P is positive, and P in fact is 15, because 15 is the distance from the focus to the vertex. And the equation is x squared equals 4py, because it opens upward. So the equation is x squared equals p is 15, 4 times 15 is 60, so x squared equals 60y. Focus is 0, negative 25. Say that this is negative 25. Directrix is y equals 25. So the directrix always behind the parabola, and the vertex is inside the parabola. So the parabola opens downwards. So the equation is x squared equals 4py. And p here is negative 25. It's negative because the parabola opens downwards. So the equation is x squared equals 4 times negative 25. That's negative 100y. Hopefully you enjoyed parabolas with center 0, 0. In the next video, I'll introduce the parabolas with center hk.